Hey folks, welcome back for another episode of Code Club. If you have been following along in the last 6 months or so, you know that I have been recreating a variety of figures, both from the scientific literature as well as the popular press and the popular media. I have been doing that because I think there's something to be said for trying to recreate other people's work. This is a lot like how if you go to an art museum and you'll see students sitting in a chair with a sketchbook, kind of sketching whatever artwork that they're looking at, right? They're trying to recreate what the original artist did to expand their own techniques and to just kind of become a more accomplished artist. Because if I only build the stuff that's in my head or using the data that I see in front of me, I'm going to keep making plots the same kind of way. They're going to become very Pat Schloss-esque, right? And that might be good, but it might also get boring. And so by trying to recreate other people's figures, I have noticed in my own skills that I have really expanded my knowledge of ggplot2 as well as other tools in R. And so what I would like to do for the next few weeks, this might be about 8 or 10 episodes, is I'm going to dig into some historical plots that I think are just really cool and that everyone should be more aware of. So the figures that I'm really interested in are presented in this book, W.E.B. DuBois, Data Portraits Visualizing Black America, The Color Line at the Turn of the 20th Century. This was edited by Whitney Battle-Baptiste and Britt Russert. And so this book has a variety of plots in it that you can see. I'm not doing a very good job of showing this, showing different types of visualizations. And here are kind of the inside page of the book, showing about 63, and I think there's been a 64th discovered recently, figures that W.E.B. Du Bois presented at the Paris Exposition in 1900. So if you're not from the United States, you might not know that 35 years earlier, the Civil War ended in the United States, ending slavery in the United States. And so over that 35 years, we would like to think that the slaves were free and blacks were free to do whatever. But we know that is a very different story, again, coming here till 2025. But one of the points that W.E.B. Du Bois was trying to present by going to Paris was to show what Black America actually was like. I will put some resources down below in the description for you to learn more about this exhibit. But one of the things that I learned as I was watching other people talk about this, and I'll put a link to a video that I thought was really good up here in the corner, was that about the same time in Central Park, New York City, there were living zoos where they would present Black Americans like zoo animals, right? So this is very denigrating, very just evil, right? And so one of the goals for Du Bois was to go to France and to show France what American blacks were actually like, and that it was a positive story. Yes, there's a lot of bad stuff going on, but they also had a positive story that they wanted to tell. And so when you look through this book, you will see visuals kind of like the one on the cover here. That's a spiral. And you might think, oh, we would never make a plot like that today. Or you'll find pie charts, or you'll find other types of spirals and other types of plots that you might think is a bit jarring and arresting, right? And I think that's part of the point, right? That if you can imagine walking by an exhibit where there's lots of things going on, Du Bois wanted to catch people's attention, right? And so showing something like this, a spiral, and people wondering, what's that spiral about, right? Or very bold and stark colors, it would get people's attention and draw them in. And so I talk about this a lot. He was telling a story with data. The other thing I find fascinating about these figures is that he watercolored them. He made them all by hand. He did not have R, he did not have Excel or Tableau or any of our modern conveniences for generating figures. He made them by hand with watercolor, pen, and whatnot, right? And so he had a team of people working with him. I believe he was at Atlanta University at the time. And so what I'd like to do in this episode and several episodes going forward is build some of the plots that I find really intriguing and that really had me scratching my head for how I would create those using ggplot2. I'll put a link for this book on Amazon down below in the description. I think it's about $20. Alternatively, you can get all of these figures from the Library of Congress for free if you want to peruse through them. I think this book does a nice job of also providing some of the context behind them. The figure that I wanted to make today is from panel 12. And so this I find to be just really simple, but really jarring, right? And so there's a few things on this that I noticed that really stick out to me. Of course, the title is Slaves and Free Negroes. Here in 2025, we do not say Negroes. I will repeat Negroes where Du Bois says Negroes, but normally we talk about Black Americans or African Americans. And so a few things stand out to me about this. So first of all, this is an area plot on its side, right? So typically we might think of an area plot going left to right. Here it's going from top to bottom with 1790 at the top, 1870 at the bottom. And this has a broken x-axis if you notice it, but I would say this is a good broken x-axis, right? They're not breaking it and showing something on the other side. They're breaking it by only going to 3%, right? So 3% was the max on the left side, but the maximum number of free Black people at the time in 1800 and 1810 was 1.7. I should add that this is in Georgia. So the first half of the collection was representing Black Georgians, and then the rest was Black Americans. And so he really zooms in, and then when you get to 1860 to 1870, boom, you go to 100% free. And so this red represents the free. And so again, I find it very arresting and very jarring, the story that he's telling here. You can also, if you look closely, notice the brush strokes in the watercolor that they made. All right, so I talked about having this jagged left side, which I think, again, shows the break in the data, that there's a lot more data to the left, but that's representing slavery. And slavery is being represented in black, which is a negative, strong negative color. One of the other things I notice is that on the x-axis, the labels are at the top, and instead of starting at 0 on the left and going to 3 or 100 on the right, he flips it. And so I think that's a really interesting choice. In addition to having the years or the decades on the left side, he also has the percent of free Negroes, as he says, on the right side as well. He has a percent sign for 100% as well as for this first value of 1.3%. And so this is kind of like a double y-axis, if you will. And so we'll have to figure out how to navigate that. He has these white grid lines, horizontal grid lines. He also has a white line dividing between the free and the enslaved Black people, okay? And so I think there's a lot of interesting stuff in here that we'll want to dig into over in our studio. So I've started creating an R script that I'll call panel12.r. I'm going to use tidyverse as well as show text to bring in fonts that were like DuBois's. Of course, these were not fonts. This is him hand printing those letters. Anyway, and so then we have this tibble showing the year, the percent slave, and the percent free. And then I've also gone ahead and started a ggSave statement with the width of 5 inches by 6.24 inches. You should know that the original diagrams were 22 inches wide and 28 inches high. So they're quite large, right? I'm not going to build such big figures, but you could go ahead and do that and then make the adjustments to the various sizes accordingly. In learning more about this collection, one of the things I stumbled upon was a GitHub repository from Anthony Starks, who lives in New York City and has really committed himself to recreating these visualizations using a tool that I think it's called Dex or something like that. It's more of a web presentation tool than a statistical visualization tool like R. But still, he's done a really good job of summarizing this, and I'll put a link to his repository down below. One of the things that's interesting is that towards the end, he has some description of the style being used in the figures. And so he talks about different fonts that are available that loosely approximate the fonts, the handwriting font of Du Bois and his colleagues that were making this. He talks about Public Sans and Charter for sans serif and serif fonts respectively. Other choices are this B52 ULCW00 for titles and this Vasarely Light for running text. There's also a special font Du Bois that was created by Vocal Type to pay homage to this visualization series. So I'm going to end up installing this B52 in Vasarely Light fonts. The other thing that Starks includes is a color palette to give us hex codes to represent the colors that Du Bois uses. So that's also very helpful. So let's go ahead and install B52 and Vasarely Light. So that's references 6 and 7 down here at the end. So I'll go ahead and open B52. And so that link brings you to the online web fonts website. And we can go ahead and download this by clicking the download button here. So this asks that you credit the author of this font. So I'm going to go ahead and copy this, and I will paste it into my R code. I don't know that I'm going to put a caption at the bottom of it because our captions don't do very well with HTML like this. And so I think it'll be more informative to put the link here as a comment. So going into my downloads, I have this online web fonts, and I've got my panel 12 directory in my home directory. I can go ahead and decompress this. And so now in here, I have the various different fonts. The other font we want is this Vasserly Light font. And so we can see this is what the Vasserly Light font looks like. Kind of would be appropriate for like the years going down the left side of the figure. And so if we come down, we can go ahead and download this. Again, I can then move this back into my panel 12 directory, and I can then go ahead and unzip that. So let's go ahead and load these two libraries, and we'll go ahead then and load the font. So we'll then do font add. So we'll put in the family name as well then as the path for the regular, and we'll come back to my directory. Let's start with the B52. So I'll go ahead and click on that and copy, and then we'll go ahead and paste in the path. So I'm in panel 12 is where I have it installed. So I'm going to remove that path from the home directory. I notice here I'm in my home working directory rather than the panel 12. So I'm going to go ahead and change that working directory. And we'll go ahead and do that by using the File tab in the lower right corner. And then we can set this as our working directory. This runs the setwd to get that. And I'm going to call this B52 as the B52 font. And now we want to do the same thing for the Vasserly. So we'll do font add, and we'll then do regular equals whatever. And so that's going to be this Vasserly Light. I'll go ahead and copy that and paste that in. And again, we don't need that part of the path. And so I'll call this Vasserly. That loads that. And so now we have the two fonts that we need to get going. So let's start thinking about it. Instead of having the year on the y-axis, let's have it on the x-axis. And so we're going to have year on the x-axis, and then we're going to have the slave and the free portions on top of that. And so we need to have slave and free be in the same column as well as the percentages in their own column. And so we need to pivot this to make it longer. So we'll do pivot longer, and we'll do minus year, and we'll do names 2 equals status, values 2 equals percent. And so now what we see is that we have the year, the status, and the percent for all the data, and there's 18 total rows. Let's go ahead and pipe this to ggplot. We'll do AES. On the x-axis again, we'll do year. The y-axis will be percent, and fill will be status. And then we'll do geom underscore area to make an area plot. And so we'll go ahead and run this and save it as a PNG. And so there we go. We now have across the x-axis our year and the y-axis the percent. Of course, we're going to want to end up flipping this to have the year on the y-axis and the percent on the x-axis. So you might say, well, why didn't you do that directly, Pat? Well, if I do y equals year and x equals percent, I get something that looks pretty weird, right? Like you can kind of see that this just looks odd, right? That's not what we want. Alternatively, what we could put this back to x and y, for x being year, y being percent, and I could add on here a chord flip. So now what we see is that we do have time on the y-axis and the percentage on the x-axis. It's flipped in order from what we want. If you read the documentation for chord flip, they discourage its use. So what they prefer is to do orientation equals y. So to put the x-axis on the y-axis. And so again, this looks weird, but now what we can do is we can represent the year as the y aesthetic and the percent as the x-axis. The orientation then is in respect to the y-axis. And so now we get back to what we had with chord flip. Of course, chord flip works, but the new way of doing things in ggplot appears to be using this orientation argument. And so it might take a little bit of time to get used to that for those functions where you can't merely flip the x and y aesthetics, right? Like we have here with geom area. So let's go ahead and match the colors that they used, and we'll also drop the legend then. And to do that, we'll go ahead and add in scale, fill, manual, breaks, free, and slave, and then values, a special hex code that I'll copy here from the style manual, paste that in, and then the slave is black, which is 6 zeros. It's upset because I put in vales rather than values. Now let's go ahead and remove the legend. And in geom area, I'll go ahead and do show.legend equals false. So now what I'd like to do is put in that white line separating the two. And so you can see there's a white line there, right? And so I think what we can do in geom area is we can do color equals white. So fill is interior coloring and color is for exterior coloring. And so there we go. We now have our white line dividing the two regions. I'm gonna wait to resize that line until we get things more kind of in the shape that we want things to be represented. One of the things I really love about this figure is that they have this ragged edge on the left side. And so this is at 3%. And I think we can model this edge with a random number between, say, like 2.8 and 3.2 or 2.9 and 3.1, drawing a random value around 3 to give kind of a ragged representation. We can then show that as a line, or if you think about it, coming back to our data here, we could cap the total percentage at 3% or whatever that random percentage is. This is going to take a little bit of work to do and is probably going to be the hardest part of this demonstration. So let's step away from building the plot for now, and we'll go ahead and remind ourselves of what we have here, right? So we have the decades and slave and free. So I'm going to make another tibble that I'll call ragged line, and that'll be a tibble. So we'll do year equals seek from 1790 to 1900. Let's do that by half year increments. And so again, what this will get us is a tibble where the year is going up by half years from 1790 to 1900. Then what we want to add in here is the max, and we'll do run if. So that is drawing a random variable from a uniform distribution, and we're going to grab the length of year. So however many values are in year, that's how many we want to grab. And the min value, let's make that 2.9, and the max, let's make 3.1. And so now when we look at ragged line, we see that we have for each year, or each half a year, we have a value that bops around 3. And so what I could see doing is joining ragged line to my tibble, okay? So let's go ahead and move this pivot longer down a bit, and we'll do an inner join with all this stuff and ragged line. Actually, I don't want to do an inner join because that will only return the years that we have in common between this tibble and my ragged line, right? And so I think what I want to do instead is a full join, and we'll join by the year. And so when we join that, what we'll see is that we have our decade data, and then we have all the other data, right? So let's go ahead and arrange it by the year. So we'll do arrange year, all right? And so now you can see 1790, we have the slave and the free and the max value, but then we have a whole bunch of NA values because we didn't have data for like 1790.5, right? And so I'm going to go ahead and add to this a print n equals 15. So we'll see more of the data. And for testing purposes, I'm going to go ahead and increase the increment to 1 year. And that way then we can see kind of the data here, and that the interpolation that we're going to try to do to make sure that interpolation actually works well. So I think what I'm going to do is do the interpolation on the free rather than the slave, because if we know the free, we can get the slave. And so really what we want to do is a linear interpolation between 1.3 and 1.7, and then 1.7 and the next value, and so forth, right? And so to do this, we need to calculate the slope, and we need to know the intercept, right? So the intercept is going to be the free value, right? And the slope is going to be the next value minus the free value divided by the number of years in between, right? And so to do this, before we do the full join, let's go ahead and make a few extra variables. So we'll do mutate, and we'll do free start. So this will be like the intercept, and that will be equal to free. We'll do the free next, which will be the next value. And to get that, we can do lead on free. So let's see what this looks like, all right? And so we can see we have free start, which is the same value we had for free. And then free next is this value, right? So 1.7 goes to there, 1.7 there, 1.2, 1.2, right? And so now what we can do is we can get the free slope being free next minus free start, and then those two, that difference then divided by 10. And so now we get the slope for each of the decades. And let's make sure that this makes sense, right? So going from 1.3 to 1.7, the slope is 4 hundredths per year. Good. 1.7 to 1.7, the slope is 0. And then obviously down here, from 1860 to 1870, the slope is 9.9. Good. And then 1870 doesn't have any slope because there's not a next value. So what I'm going to do with this data to kind of walk you through it is for each row, I'm going to calculate a new free value, right? So from like 1791 to 1799, I have NA values. But I know the intercept, the start, I know the slope, right? And so from the slope and the start position and the year, I can calculate the percent free. From the percent free, I can then get the percent slave. So to fill in those values, after we do the arrange, we can then do fill, and we'll do free start, free slope. So what that fill function does is it fills in the values of the preceding value. And so that's why it was important to sort the data by year first, right? Now what we can do is we can go ahead and do mutate free, and I'm going to say free calc. We'll put it to free here in a minute. We'll do free start plus free slope times year. And it's upset because I have too many parentheses here. Let's go ahead and pipe that. And so now what we see is that we have our free calc, and that is wrong. That is wrong. What did I do? What did I do? I'm multiplying it by the year, and really what I want is the number of years since the decade, right? So like if we're looking at like 1791, I want that to be 1, not 1791. And so an easy way I can do that is with the modulus operator and modulus 10, right? So if I do 1791 modulus 10, I get 1 back, right? And so then this will get us the number of years since the year that corresponds to the free start. And so now what we see is that our free calc starts at 1.3, as it does over on the left, and that it ends at 1.7 as it does over on the right. And so our free calc, I think, works. So let's go ahead then and assign this back to free because we don't need that extra column. And so now we see we have year, slave, and free. And so now we have our free value. And for the most part, these free values are going to be below our maximum value, right? And so, but if our free value is above the max, then we want to bring it down to the max. So we'll do free equals if else free greater than max. And again, max is this column on the far right. So if free was, say, 3 for 1790, then we want to return 2.95, right? So if free is greater than max, we want to return max. Otherwise, we want to return free. And so again, for the most part, that doesn't matter. But if we look at the tail, let's go ahead and do what we did here and look at the last 15 years worth of data. And so let's see. I'm noticing that the last 15 years worth of data, the free is the same as the max. And that's not right. So I'm a little bit worried. So let's back up here a second. And let's go ahead and remove this if-else statement. And we'll get rid of this final comma. And so now what we see is, let's see, 1886, free start, free slope is 9.92. That's not right. That's not right. So let's come back a little bit further and let's put in a tail here. So we'll do tail n equals 15. And what I'm noticing is like my 1890 doesn't have my free start or my free next or my free slope. Oh, I realize I don't have data going to 1900. I have data at 1870, right? Right? And so my year here needs to go to 1870, not 1900. All right. So now when we run that, now we get 1860 to 1870. Now we can fill in the rest of those values by removing this tail. Good. And so now what we see is that 1870, it goes up to 100, but at 1860, it's at 0.8 and goes up to 100 over those 10 years. Okay, now we're good. And put back in this cap on our free value to be no larger than max. It's unhappy with me, probably because I forgot a comma. Now we've capped our free value to the max value, right? And so we can see that, right? So like at 1858, our free value is 0.78, the max is 2.94, right? Whereas like at 1869, we have 2.99 as our free value, and the max was 2.99. So now we need to add in the slave value. So we'll do slave equals, and we'll do max minus free, right? So otherwise we would have done like 100 minus free to get this percent slave, but now we're gonna do the max minus the free. And so now we have year, slave, and free. And of course we can see the zeros there for that slave column. And so now we can select those columns. We want the year, free, and slave. And that gets us those last 15 years for those three columns. And now what we can do is bring it in to pivot longer to go ahead and put our free and slave column names in the status column and our percentages in the percent column. Basically, we now have the data that we started with, but we've added years to be in between those decades, as well as to cap it at an average of about 3 percentage points, right? Let's go ahead and save this as slave free, and then we can take slave free and we can pipe that into ggplot. And we get some pretty gnarly stuff. I believe this is because we have the slave underneath the free, right? And so the free is going to have the more smooth edges between the decades, right? Between like 1790 and 1800, whereas the slave is going to have much more of that random bounce. So we need to use a factor to put free after slave or free before slave. We'll experiment. I'm not exactly sure how it should go, but we'll figure it out. We'll do mutate status equals factor on status, and then our levels. So default, it's alphabetical. So go free and then slave. And so that's not working. Let's do slave and then free. So we'll do slave and free. So now we have the nice smooth edge between the free and the slave, and then we have the rough edge at about 3%, right? So now our image is basically the reverse and flip of what we're going for, right? So currently 1870 is up at the top. We want it at the bottom. 0% is on the left. We want it on the right. We want this ragged edge on the left side. We can do that with our scale continuous functions. And so let's go ahead and here, after the scale fill manual, and we'll do scale x continuous. And I think we can flip the order of the limits. So we'll do limits equals c, and then let's do like 3.2 and 0. I believe 3.2, oh, it was 3.1 was the max. So let's go ahead and make that 3.1 because we're not going to have values larger than that. So I think this will flip the order of our axes. Nope, it removed all our data. So I think what we need to do if we're going to flip the order of our limits then is to do transform equals reverse in quotes. And so now we have 3 on the left and 0 on the right. Very good. And I think we can do the same thing with the y-axis. So let's come back up here and we'll do the same thing. We'll do scale y continuous limits equals c 1870, 1790, and then transform equals reverse. Very good. Now we have 1790 at the top, 1870 at the bottom, and basically a very similar looking plot, right? Of course, we still have a fair amount of work to do. Let me tell you kind of the kludge that I would normally do instead of this transform equals reverse. What I might normally do would be to do like y equals minus year, x equals minus percent. That then tricks R into thinking we're going from minus 3.1 to 0, right? So it's going to put that roughed edge on the left, and then it's going to flip the order of our years, right, to put 1790 at the top because it thinks negative 1790 is more than negative 1870. Then what you could do in our scale continuous functions is to use the label argument to basically remove those negative signs. But I think this transform reverse with flipping the order of the limits does a much nicer job, and we'll roll with that. So let's go ahead and deal with our titles. So this title is Slaves and Free Negroes, and we'll go ahead and add that after our geom area. I'll do labs, we'll do title equals Slaves and Free Negroes, and then our x, we don't have an x, so we'll do x equals null, y equals null, and get a plus at the end of that. And so now we've lost those axis labels, which is good. Let's go ahead and use our font for our title and go ahead and center it. And you'll recall that our font name was B52 for the bold font. And so we'll go ahead and add theme. We'll do plot.title equals element text family equals B52. And we'll do hjust equals 0.5. And it didn't use my font. And I think that's because I forgot to do the rest of the show text stuff, right? So we need to do show text auto and then show text opts DPI equals 300. And so these are necessary to actually load and have the fonts persist and get the right screen resolution. Now we have our font across the top. That looks good. We'll come back and deal with the margins and whatnot in a bit. While I'm thinking about it, why don't we go ahead and reduce the resolution of our years? Maybe we can take that down to a half year. And so we had that back up here with this ragged line. And so I think that's a pretty good interval. I feel though that the width of that raggedness is too wide. So again, we were doing plus or minus 0.1. Maybe we could do plus or minus 0.05. And that's still a bit more jagged than what they had on theirs, but I think that's going to do pretty well. We're also going to make the plot a bit more narrow like theirs, and so that might hide some of the lateral dispersion in that raggedness. So let's go ahead and remove the expand that's around the plot, and we can do that in chord Cartesian with expand equals false. Let's go ahead and put this x-axis text up at the top, and you'll notice theirs doesn't have a 0, but does have 1, 2, and 3 with the percent signs, right? And so we'll do that in scale x continuous, where we'll do position equals top. So that should move it to the top. And then we'll do labels, and we'll then do C. We'll do then 3%, 2%, 1%, and then an empty string for the 0. And that flipped it on me. So we need to reverse that order. So dealing with reverse orders can cause some headaches, right? So we've got 0 here, but that's actually 3, right? So let's turn it around. So we'll go ahead and do double 1%, 2%, 3%, and then we'll get rid of this last thing. And now we have 3% on the left going out to right. We do have a tick mark there, and I see a tick mark there as well. We also have a font, right? And so that's that Vasarely font, Vasarely, yep. Since all of the fonts other than the title are that Vasarely font, let's go ahead and do text equals element text family equals Vasarely. And so now you'll see that we have that thinner font for our percentages across the top, as well as our years on the Y. While we're working on the x-axis, let's go ahead and make those tick marks thinner. And so we can do that here. We can do axis.ticks.x equals element line. We can then do line width equals 0.25. And so that narrowed it up quite a bit. Pretty nice. And then let's shrink the font up there. I don't totally know what it's going to be in the end, but we can kind of get it started. So we'll do axis.text.x equals element text. And then we can do size, let's say 6. Yeah, I think that actually might be pretty close to what we want. It's actually a very small font, right? Cool. Now let's turn our attention to the y-axis, where we're going to want to go from 1790 to 1870 in 10-year increments. In scale y continuous, we can then do breaks equals seek 1790, 1870 by 10-year increments. And so then this gets us our years. Good. They don't have tick marks, right? So let's go ahead and remove those ticks. So we'll then do axis.ticks.y equals element blank. Again, that drops out those. And we can also remove the background. And so let's go ahead and do that here. We'll go ahead and do panel.background equals element rect fill equals white. And so that got rid of that. Let's go ahead and get rid of those grid lines as well. So we'll do panel.grid equals element blank. I guess we don't know if they're there or not because the grid lines themselves are white. And so if I put the background back in, we do see that the grid lines are gone. So we can uncomment that. So one of the other big things that we still need to add are the numbers on the right side. But we need to draw in the plot with having some margins on the left and right side, right? Let's go ahead up where I have this plot title and we'll do plot.margin equals margin. And then on the left, let's make it say 30. On the right, let's make it 30. So that brings it in. We can still come in quite a ways. So let's maybe make it 60 and 60. So kind of comparing the two, we see that there's a lot more we can come in. So let's make it 90 and 90. All right, so the one on the left I think is good. On the right, maybe we can bring that in to say 110. And I think that looks pretty good, right? So we lost the margin on the bottom and the top though. So let's go ahead and bring in the margin for the top. And so we were doing all that margin fiddling here. So let's do t equals 20. I think that's good. Maybe we can shrink the size of the font a bit. And so we'll do size equals, let's try 10. And let's maybe up it to 12. So we need some space now between the panel and the title. And so our title can get a margin as well. And so we can then do margin equals margin. And then I think the T is going to be a 0 and the B, let's go ahead and make that 10 for now. Okay, so that brought it down, but let's go ahead and bring it down a bit more. And so we can maybe try 20, and I think that's pretty good. That needs to come down because we're going to have to put this % of free Negroes text in between, right? Now we need to bring up the bottom by putting a margin on the bottom of the plot. And here then we can do B equals, let's do 30. So we see it can come up even further. Maybe it could go up to 70, say. And I think that's pretty good. And so I think our dimensions are pretty good. And I think the font for the years looks pretty right. We could maybe add some more spacing between our text and our edge here. So we could do that by expanding the Y limit, or we could add margin to the right of our numbers. Let's add it to the right of our numbers. So we'll need to add that margin to axis text Y. And we'll do element text, margin equals margin, and then R is going to be, let's do 10 just as a place to start. So I think that's a pretty good space then between the year and the rest of the plot. Now we want to put this % of free Negroes in the right-hand margin. And I'm going to do that with geom text, and we're going to be plotting that outside of the plotting window. And so on the X and Y axis then, we need to allow the data to go outside of the margin, right? Because we're going to have this % of free Negroes up outside of the plot. And so because we're going to do that, we need to move our limits into chord Cartesian. So let's go ahead and grab the limits here that's for the X. And so this will be xlim. And then for the Y limit, we'll grab that. And then ylim. And so let's run it just to make sure everything works because we haven't changed anything yet. Good, nothing changed, nothing broke. And then also in chord Cartesian, we're going to need to add clip equals off, because otherwise if clip equals on, then it's going to remove stuff that falls outside of the plotting window. Nothing's changed. Now we, again, are going to want to use geom text to place these percent of free Negroes in that margin, okay? And so we need a data frame to do this with, right? And so we could go back to the original data and maybe we could break this up a little bit. Why don't we do that, right? So let's go ahead and make this then our top line, and we'll have slave free come into top line. And then this is going to need to be top line, and nothing's changed. Good. So then for slave free, let's go ahead and mutate this to make a label. So we'll do mutate. So we'll do pretty free. If, we'll do if else, right? So if the free is from 1790, it needs a percent sign, right? And if it's from 1870, it also needs a percent sign. So if year equals 1790 or year equals 1870, then we're going to want to do paste 0 of free with a percent sign. Otherwise, we want free. And why are you upset with me? And it's upset, can't combine true, character, and false double. So this free then is a double, whereas this is a character. So we can fix that by doing as.character on free. And so now we can look at slave free, and we see that we've got the percent sign for 1.3 and 100%. Let's make sure that top line and everything else still works. Good, that's great. And so now we can come back into our pipeline here, and under geom area, I can do geom text, and we're going to use data equals slave free and AES. On the x-axis, we're going to put that in the right margin, right? And so again, we've got to think about our reversed axes, right? So like, I'm going to maybe think that this is at like negative 0.3. And so let's do negative 0.3. Let's put in a leading 0 there because I like that. And then y, let's go ahead and put in year. And then label, let's make pretty percent. And then we're going to want to inherit AES equals false because we don't have, we do have percent, we don't have status, right? So we've got basically a different data frame. And so we need to tell it to not worry about those other AES statements. So let's go ahead and see what this looks like. And it's upset because pretty percent not found. What did I call that? Oh, pretty free. All right. I can't do things without making mistakes. That's fine. Pretty free. Now we have our pretty free. A couple things that these are center justified. And so I think we want it to be left justified as I kind of look at their plot here. We also want the Vasily font. And we still might want to move things over right to the bit. And so here then we can go ahead and do family equals Vasily. And then we can also do hjust equals 0. And then size. The size looks like the same as the year size, but I'm not sure what size that was. So let's go ahead and do 8 and then size.unit equals pt. I'm not getting that font and I'm getting warnings, which I think means that I probably misspelled the font names. So let's just run the warnings. Yeah, font family Vasily not found. I don't know. Oh, let's see. Let me copy and paste from what I knew worked. Okay, yep, I misspelled it. Now we have the font, and it does appear to be the same size font as the year. And now we want to put the title on top of that, the percent of free Negroes. I'm going to do that with an annotate. And so we'll come back up here to where we had geom text, and I'll do annotate, and then geom equals text. And our x is going to be the same x as we had here, so 0.3. And then our y, at the top was 1790. Let's go ahead and put it at like 1785. And then our label, we'll do percent of free Negroes. And then we've got some line breaks around the of, right? And so I'll turn off my caps lock to get those breaks in there. And so let's see what this looks like. Percent of free Negroes right there, right above. And so our numbers are left justified on negative 0.3, but this is going to be center justified on negative 0.3. So I think we are going to want to move it over a smidge to the right, but clearly we need to make our font smaller and our line height quite a bit smaller as well. So coming back up to our annotate, let's go ahead and do negative 0.4. We can do line height equals 0.8. And then our family is going to be Vasserly. And then our size is going to be smaller than the labels, which were 8. So let's go ahead and make it 6. And then we'll do size.unit equals pt. So I think we can bring it down closer to the number. Let's go ahead and make that 1787. And maybe we need to go up a smidge. Let's go up to 1786. So I think we might want to make the font a little bit smaller. That or we're going to want to move everything over to the right a little bit more. So let's go ahead and make this 5. Yeah, so that's smaller, and I think it's closer to what they had. But I think we're going to want to move everything over to the right because that free is right on top of that tick mark. So let's make this negative 0.5 and this negative 0.4. So I think this looks pretty good on the right side. We could probably tweak things a little bit more, but I'm going to leave it as is because there's more stuff to be worked on, right? Let's go ahead and add our grid lines for the year. So they have white grid lines going all the way across. The other thing that I noticed is that their top line here is black. So I want to do both of those features. So let's start with the grid lines. And to do the grid lines, because our natural grid lines that we control with the theme function fall under the plot, we need to draw on top of the data horizontal lines. So we'll do a geom h line, and then we'll do y-intercept equals, and we'll do seek 1790, 1870 by 10. And then let's go ahead and make this color white. And so those grid lines are great, but they feel a little bit strong compared to what DuBois used. So let's make them a bit thinner. In geom h line, we can do line width equals 0.25. And then let's use the same line width up here in geom area for that line, right? And I think that's a much better, much more nuanced thickness to the line. There's one subtle difference that if you look at mine and DuBois's, you'll notice a difference, right? And that is this line, right? And so the line from 1860 to 1870 is a lot sharper of a slope than mine, right? And mine is going out to 100. And so I think if I wanted to replicate the slope on his line here, instead of going out to 100, I'd probably need to drop that to maybe like 30. So let's try that and see what happens. And so back up here, let's go ahead and put in 30. And I'll go ahead and put a comment in there. So that made a very small change that's almost imperceptible. Let's go ahead and bring that down to say like 10. And that is a lot closer to what he has, right? Again, I think he may have moved that line down a little bit to make it more clear that this happened over the course of the decade versus having that line kind of be more shallow, if you will, doesn't quite give that impression, right? And maybe we could leave a comment up here that it was adjusted to 10 to highlight slope of line. One last component that I almost forgot to add was having a black edge. You'll notice that their grid lines actually don't go all the way out to the edge, and that down here where there's the free is breaking through, right, because of their liberation, there's a black edge. So let's go ahead and add that black edge, and I'm pretty confident that we can do that with geom path. So let's come back up, and we'll want that to be on top of our area plot. So let's go ahead and do geom path. On the y-axis, we'll want the year. And on the x, we'll want the percent total, or actually the max value, right? And so I think maybe we can grab that from our ragged line, right? So let's go ahead and take ragged line, and we'll use that as the data for geom path. So we'll do data equals ragged line, AES, y equals year, x equals max, and then we'll do inherit AES equals false, and we want that color to be black. That's going to be the default anyway. And so now you can see down here especially that we have that black edge. So that line is a bit thick, I'm noticing. And I'm noticing that the grid line actually goes all the way to the edge. So I think I forgot to put geom path after geom h line, right? And so in here, let's go ahead and make it thinner. So we'll do line width equals 0.25. I think that's good. So we've got a nice thin line, as well as our grid lines don't go all the way to the left-hand margin. Hopefully you enjoyed making this figure with me. Some of the things that I thought were, I guess, the challenging parts of this figure were getting this left-hand margin to have some jaggedness to it, right? Basically flipping the order of the X and Y axes was challenging, and we saw we could do that in the scale continuous functions by switching the order of our limits and then using transform equals reverse as an argument. The other thing that we incorporated then was this text in the right-hand margin, which I added with geom text, but again, by defining our axis limits within chord Cartesian and setting clip equals false so we could put that data in the right side. We also saw how we could import fonts to get this special B52, as I'm calling it, font for the title and the Vasserly font on the rest of the text in the figure. Let me know what you think of recreating these historic plots. One of the things that really stands out to me is the organic nature of the originals, right? Like you can definitely see that these were painted, whereas mine, not so much, right? It's straight up red, straight up black, and there's no variation in the color. And so I think having them be handmade kind of adds to the story of why DuBois and his colleagues went to Paris for the exposition, to show the humanity of the Black Americans who had recently freed in the last 35 years. Whereas, of course, our modern data generation, data visualization is fairly clinical in its precision, right? And so I think we kind of see some of that in the storytelling that we do with our data. Let me know what you think about this. Also, I would encourage you to look back through the collections of the plates from the Paris Exposition. Let me know if there is a plot in there that strikes your fancy that you would like to see me recreate. I have some lined up in the future episodes here that I think are quite challenging, that will really push me, but I'm really looking forward to going through those with you. So that you don't miss those upcoming episodes, please make sure that you've subscribed to the channel and you've given this video a thumbs up, and we'll see you next time for another episode of Code Club.